Okay, this is the second part of the video. We're going to go to page 38 and finish using set up the Visual Basic module here. So hopefully, like you did in the first one, you added in the Visual Basic tool pack. And so you can go here to Developer and start a Visual Basic part. There we go. And so I can type in option explicit. Because I'm going to write a program there, and then I'm just going to type in what you see on page 38. There, this is the function Euler, which is giving me the change in time, the initial time value, the finishing time value, my initial y value, what my mass is, and what my coefficient of drag is. So I'm going to claim h as double, time as double precision, y as double. I better make sure I capitalize this A. And dy dt as double. So t is going to be my initial time, and y is going to be my initial y value. H is going to be the change in time. And so I'm going to do this thing. If t plus dt is greater than the finishing time, then h is going to be that little difference between there. And that's going to end that if statement. And dy dt is going to be this new function, dy tymcd, which I'm going to write at the end. And this is Euler's formula right here. My new y value is going to be my old y value plus the slope at that point times my step size. And then my t, new t, I'll increase it by whatever my h value is. Not t, h. And then if my t value eventually gets to be bigger than my ending part, then I'll exit. I'll loop around this. And my result then will be the y value. And then that's going to end the function. Now, if you look at the bottom of page 38, there's this little sub function. This is the function dy, and my inputs are time, velocity, mass, and coefficient of drag. I'm going to have to determine what my gravitational constant is. I'm going to make this double as double equal to 9.8, and dy will, the change in y will be my gravitational constant minus my drag coefficient. Okay, and that's going to be my add function. So then I could compile this if I'd like. Hopefully it'll work. And then I'll come back to the original part. I'm going to put equals 0 here, and then I'm going to call my Euler function here. So my call for my Euler function will be dt, my previous t value and my current t value, and what my previous y value is, and then my good old mass and that. And so that should then be what my Euler's function will predict, and I can continue this and drag this down to get all the different values that I got there. And the thing is, we can do this is now, like, say, okay, suppose I didn't weigh 168.1 points, I could put 100 pounds, and this kind of compares what the Euler's method would get with the actual true analytical approach we might get on the right. And we could change the coefficient of drag, and we could even change the time too. If we said instead of 0.1 seconds, we could have like 0.005 seconds, and it would give me some different values at this point that would calculate in between. So that's just sort of how you could write a simple Visual Basic program. And
Hope this helps.